Hey guys, welcome back to my channel. Thank you very much for coming. For this video, we're going to go backtrack a little bit where we talk about exponential graphing. We'll be using Desmos graphing calculator. As you know, go on to Desmos graphing, then all you have to do is to select the plus sign and add your table. And your table will direct you to the numbers you need to put into the X and to the Y axis. So here we go. So add tables. Now we're going to put in our values for X, values for Y. If you have commas within your numbers, do not put the commas in Desmo, as Desmo will not recognize the commas. So right here, we are going to be seeing our graph popping up to if it's linear or not. We basically change our scale so we can see how appropriate this model is. And here we go. For the scale, go to the top right hand corner of your screen and you'll see the toolbar. Click on the toolbar and you put in your X values, your Y values. So what you do is for X, you do the smallest value of X and then the largest value of X, and the same for Y. However, if you don't want to use the exact numbers, you can always make an approximation like you see me doing here. I went from 0 to 12, and for my Y, I went from 0 to 20. So once I have that, now it's time to see my graph and how it's looking. Very good. So to me, it looks exponential and it's going downwards, so I know it's a decay. Now I need my equation. So y1 is equal to our squiggly ab to the x1, and x here goes in the exponent. Use your keyboard, guys. It will help you to determine the values. So the small ab icon you guys saw right here is the one that we use to put our exponents in. So let's go. So once we have that, then you'll see your A value, your B value. And again, right here, as you can see, the B value is your slope, and that's 0.718. Then you use a decay, because it's no longer 1 or above 1, so it's a decay of whatever it lost. If you look on your screen, you see your graph looking very nicely. You can observe that graph and the E-plot, which is your residual, to see if the model was accurate, overestimate, or underestimate. So right there gives us everything. Now to tell if your model is appropriate or not, you always check the E-plot. Your residual plot tells the appropriateness of your model. Is your model linear or is your model non-linear? If it is linear, you go ahead and check to see if the dots are randomly scattered. If it is non-linear, meaning exponential can be used, then you'll see a curve. So right here, you see I click on E-plot, it's showing me my residual plot in red. If you look at it, you see a peak right there. It starts from the bottom up to the top, down to the bottom again, and it keeps flowing. With this one, I would say the exponential model is appropriate because there's a pattern that exists. But if you don't see a pattern, you write what you want to, because it's what you see and not what I see. So once you have that, you all know how to write the equation of the line. So y is equal to the A value, 26.0692. The B value, in parentheses, 0.7, 0.71 to the X. And here you see your E-plot. And this E-plot will basically help you to see the predictions the model made. And as you can see, there was no accurate one. They were close enough to the line, but not directly through the point. So, yeah, there we go for our graph. Thank you guys for coming. See you all soon.